Welcome to the second lecture in the Lecture 5 series, Generic Innovation and Interaction of the Innovation Elements. In this lecture, we'll be talking about the interaction of the elements, and I've already mentioned several times, including in the introduction to this Lecture 5 series, that it has been very, of course, difficult as we collect the sort of potential market applications, the potential implementation, and potential technologies, not to think about the other categories. And we've purposely developed that way because at the beginning you want to open up your mind and think about as many things as possible if you're trying to get a more fundamental innovation advancement. But as we go forward in the innovation process, we have to use this element to interaction to our advantage in order to converge on a useful innovation in the marketplace. So let's go forward and talk about that. So we've mentioned our pen example throughout the different development of the elements, and to clearly show the interaction, the technologies that we decide to add, modify, or work on clearly affect the market application. So in other words, let's suppose that I have, and this is how it often starts in my career, for example, where I started as an engineer and scientist. I had particular technologies that inherently I felt if we made advances, they'd have fundamental application across many applications. And as you'll see later, we'll talk about how if you work very far out, that's what you want, because you can't really tell how the technology changes and how the market would evolve over time. So you want to do such a fundamental advance that it affects so many things that in the future you'll have a chance at hitting a market application. So that's an example of a direct impact there, where let's suppose that we'll be talking about the strained silicon example. In that case, the fundamental development had to do with an interest in trying to put two different kinds of different semiconductor materials together that kind of generic problem had a problem, and so you weren't able to really build new kinds of integrated circuits and chips and things like that. And so it was clear that regardless of the particular end segment, if we made that advance, it would find a home probably. I mean, you can't be for sure, but in one of the application spaces that we were thinking about. Now, as we work on them, and either we discover new things and add more options or modify them, because as we work on them, we realize, hey, it's not going to work out for this, then clearly that affects the market application. So if I thought, oh, I'm developing this technology and it's going to result, again, let's use a semiconductor example, that strained silicon is going to allow people to use the same factory that they had, but to produce better circuits. But then all of a sudden, as is in the real case, when we looked at this technology, the first version was good enough for advancing the current state of the art. And so then we're moving from one kind of application, more or less a trailing manufacturer, an integrated circuit company and what they're after, versus applications that are, once again, leading edge, like microprocessor and things like that. So the way that technologies evolve, what we decide to drop, pursue, or the things we see along the way affect which applications we can go for. I think that's a pretty straightforward thing. And of course, just to emphasize the reverse, that if for some reason as we're doing this we find out that we have unique, a lot of times it's a very practical reason why you choose a particular application. For example, you might have contacts in a particular industry. So for example, at one point we had particular contacts into the FPGA market, a particular kind of generic integrated circuit that is programmed with software. And so what can happen is you say, all right, I want to think about that market application because we have particular insight in there. And as we're developing our technologies, it may bend us and say, aha, those guys said they really need that. I can see how if I change my technology a little bit, it can actually go in there. So clearly market application can also influence technology. So there's a very good example. And we use market and technology as an example of how they influence each other first, just because I think it's a little bit more natural. You can see how, with some practical examples that I just gave you, real life examples, it's pretty easy to see how they influence each other. But it's true for all the elements, and we might not really be, it might not be as easy to see, but the way we choose implementation will affect market application, and in turn will affect the types of technologies we can manufacture, vice versa. So, for example, suppose that my business model is such that I am going to insert myself in the supply chain, and I may have vertical knowledge above me, and below me in the supply chain, but I'm actually not going to actively do those things myself. Essentially, other people will be doing them. So the traditional way of looking at that is somebody below me in the supply chain, I'm outsourcing, and then I'm selling, above me in the supply chain. So example there, if we continue with our semiconductor thing, we had a new semiconductor technology called strained silicon. So we had to have somebody make it for us, and then we wanted to insert it and have it appear inside some integrated circuits. So we're kind of inserting ourselves into a supply chain. Right away, that choice is going to affect which markets we can go after. For example, microprocessors currently are, at that time, were controlled by integrated companies. So, of course, by choosing that particular kind of implementation, it meant that, well, initially, we ourselves are not going to, affect the microprocessor industry. Now, it turns out later that it changes again, and we went into a licensing mode. And of course, in the licensing mode, of course, you could affect the microprocessor. So again, you can see how changes over time in implementation clearly can affect whether you impact a particular market. In that example, we're talking about whether we impact microprocessors or not. But of course, it's intimately then related to technology as well, because let's suppose that I go back to the example where I'm going to insert myself into supply chain. I need to have some people supply what I need into strained silicon, and then I'm going to supply it to particular kinds of applications that are not microprocessor, that are more existent in the foundry model where the supply chain has been disaggregated. Then the way that I develop those technologies is different because, for example, if I'm disaggregated like that, and I have suppliers feeding into, let's call it, us, where we're inserting ourselves in the supply chain here, and then, let's suppose it goes off to a foundry like we described before, TSMC or someplace like that, then I'm going to create technologies that allow, if I can, I'm going to invent around these interfaces so that the technology I'm trying to insert doesn't disturb them. Because when you have a disaggregated supply chain like this, and they're not all in one company, these folks have to know, how to get it to you. And if you change too much, it's not going to work. So you kind of, would want to use, for example, some version that's easy for them to make inside your contribution. And then when you pass it on to the foundry, of course, you want it to look exactly like, if you can, something they've already seen, so they don't have to do too much, right? Because that eases, of course, your ability to insert this and bring value to the end customer. So, again, the choice then of doing this model, a particular kind of implementation, in turn affects how you invent different kinds of technology. In fact, we have in our solar company, which we'll probably give examples of later in this class, we have invented on purpose for this kind of thing, basically inventing new materials technology around the actual original innovative technology in order to have it be absorbed by the supply chain more easily. And what's interesting about that is those inventions are as valuable as the original, because anybody who's going to try to follow your same model and implementation by inserting yourself, say, in this level, if they're going to follow you, they have to go through that same thing, because if they do something very complicated here or here, it's going to be a disadvantage. So in fact, those inventions that allow you to be seamless, let's say, and work with partners in a supply chain are going to be very valuable as well. So it can cause you to invent actually new technologies that give you more options in the innovation process. And of course, our restaurant example that we gave, just again, here I've used a semiconductor example, but I want to make sure you understand the generic nature of all this. So if I go back to our, nice underwater restaurant, that underwater restaurant, indeed, if you think about how the different elements affect, the first thing you say is, all right, I believe that there is a segment of the market that will be willing to pay maybe a little bit more for the expected extra cost that I'm going to have in inserting this technology underneath the water. And so you're already interacting with them right there, market and technology, and implementation, because you're saying cost, the business model, is going to somehow be made up. So for example, if I do put this in, attach it to, let's say, a museum, then I can make a new kind of business model where I'm just making this up, but part of the admission fee is sort of some operational cost that helps me out and then reduces the numbers that I have when I operate this business inside underwater. Very similar to other restaurant businesses. And so there I have part of the fee coming from the museum ticket and part of the fee coming from the normal operation of the restaurant. And that's just an example of how that goes. And so you can see how the implementation is being affected by the technology. And of course, you're going after a market where you think that you can get enough revenue. So hopefully you can understand in that example how the different elements interact. So that's the interaction part. And now let's, in the next lecture, talk about what does that mean. How do we bring this all together in our innovation model? Because we got the three elements, and we pointed out how generic they are for any kind of innovation. And then we showed how they all affect each other. So in the next lecture, 5.3, which is the last lecture of the generic innovation and interaction element lecture series 5, we will finish by bringing that all together into a more advanced graphical representation of what's going on.